Okay, now for problem 35, you're asked to solve this equation. You're given that log base b of the quantity of x plus 3 is equal to the log base b of 8 minus the log base b of 2. Well, b is the same base in all of these, which is really nice. So you're going to leave the left side alone of this equation. You're going to simplify the right side, because this is the log base b of 8 divided by 2, because it's subtraction here. So you're using your law of logs right here. So you have log base b of 8 divided by 2, which is 4. And since b raised to now you have b raised to something is equal to 4, and b raised to something is equal to x plus 3, then x plus 3 must be equal to 4, because those are the two exponents with like bases. So now you can just solve that as x equals 1. Okay, now number 41 has some different parts to it. And you're given that if f of x is equal to log base 2 of x and g of x is equal to 4 to the x, first of all, find f of g of 3. Well, f of g of 3, first you have to find g of 3. So you put 3 in the x in the g function, and you get 4 to the third. So now you plug that in here for x here, and you get f of 4 to the third. Then you put 4 to the third in for x in the f function. So f of 4 to the third is equal to log base 2 of 4 to the third. Okay? Well, 4 to the third, we need to get this as a base of 2 so that we have the exponent to pull off. So 4 is 2 squared. So we're going to substitute in 2 squared right here for the 4. And then you're going to, that's raised to the third. So then you really have 2 to the 6th. So that's just simplifying that with your laws of exponents. And now you have 2 raised to the 6th. This is asking log base 2 of 2 to the 6th. Well, that's just equal to 6, because that says 2 raised to what power is equal to 2 to the 6th? 6. Okay, now for part B, I'm going to leave that up there because part B says find g. Now you're going to substitute into the f function first, and I'm missing a parenthesis here. Should be another parenthesis over here. G of f of 1/2. We'll put that parenthesis in there. And so you're going to put the 1/2 into the f function first. So that's the log base 2 of 1/2. 1/2 goes in here for the x. So g of log base 2 of 1/2 means you're going to put log base 2 of 1/2 into the g function, which means it's going to be 4 to that power. So 4 to log base 2 of 1/2. Well, this says, what you have to notice here is, note that 4 to the minus 1 is equal to 1/4. So 4 log base 2 of 1/2, 2 to the minus 1 is equal to 1/2. So this log base 2 of 1/2 is equal to minus 1. So this is 4 to the minus 1. Well, 4 to the minus 1 is equal to 1/4. And this should say 1/4. We'll fix it. Okay. Now in part C, I rewrote f and g here because they want you to find g inverse. So if f, and these are the same as the ones up above, the first step is to find g inverse, because they really want you to find g inverse of 12, I think it is. So the first thing you're going to do is you're going to find this g inverse. We have to take g of x. Step 1, this is a review, exchange y for g of x. So put y in equals 4 to the x. Now replace your y with your x and your x with your y. In other words, switch the two around and rewrite the equation. And now solve for y. When you have an exponent in the an exponent that is your variable that you're solving for, you need to take the log of both sides of the equation, because when I take the log of 4 to the y, it, by our logarithm laws, it will bring that y down in front. So I'll have y times log base 2 of 4 is equal to log base 2 of x. Now I'm using base 2 because that's what our other ones were given as. So once I take the log of both sides and then solve for y is just equal to, we'll take your log base 2 of x divided by your log base 2 of 4. And that's what y is equal to. Well, log base 2 of 4 was 2 raised to what power is 4, gives you 2. So this log base 2 of 4 is equal to 2 and simplifies there. Log base 2 of x we really don't know. But now replace y finally with g inverse of x. G inverse of x then is equal to log base 2 of x over 2. Now the final step was they wanted us to find the g inverse of 16. It was 16, not 12. So f of g inverse of 16. So once we found the g inverse of 16, okay, which was the 16 put into this, because I rewrote the g inverse down here. So put the 16 in for your x here, put it into the f function, okay, so substitute that into this function for x. So you now have f of log base 2 of 16 over 2. Well, log base 2 of 16 says 2 raised to what power is equal to 16 over 2. So this actually is equal to 2 because 2 raised to the 4th is 16. So this is just 4 up here divided by 2, which means it's the f of 2, which is, if I put 2 in here, I get log base 2 of 2. 2 raised to what power is equal to 2? 1. And that's it for that set of problems.